Okay, everyone, welcome down to the Building Performance Hub podcast. Today we have with us Stan Admiraal from Sega. Stan, welcome to the podcast, and thanks for taking time out of your busy day to come and chat with us. Are you well?
Yeah, all good. Thank you for inviting me.
Good, and glad to have you down. You've got an interesting background. I've been stalking you online as I do all of the guests. So first thing I picked up was, it looks like to me you trained in architecture, so you went to school. What point did you want to become an architect? Is that something from being a small child you wanted to become an architect?
To be honest, when I was really little, when I was at primary school, I wanted to become a vet. So it's completely different. But then I think as soon as I went to secondary school, I found out I was good at math, good at science, good at art. So then I really started enjoying things, and I thought I didn't want to be a mathematician or anything. I wanted to be something more creative. So then I thought architecture, and then from when I was 13, we had actually a project at school to design your future house. And then since that moment onwards, I always wanted to become an architect.
Yeah, well, you must be a switched on cookie. We've spoken before about how it's not easy to become an architect, especially in the Netherlands.
Yeah, exactly. As in the Netherlands, it's slightly different than in the UK. It's like in the UK, it's architects more like art. In the Netherlands, it's like a technical university you have to go to. So you study building engineering, and then you specialize into architecture.
Do you think that's better? I'm going to put you on the spot. Does that make you better architects, or is it just a different way of achieving the same goal?
I think you probably need both. I think maybe if you study it from a technical point of view, it limits in creativity. So you get university professors that say, oh yeah, nice, you made this nice design, now build it, from quite a beginning at university already. So therefore it limits your creativity in shape, etc. To the only thing, the good thing is that you design things with materials that are available on the market. And therefore also at university you already have to start really researching into what materials are available, what do they do, what are their capabilities, etc. So therefore you have a bit more knowledge about the materials than if you focus directly onto the art. And then you have to, of course, you still have to, if you do like building engineering in the Netherlands, then only 10% of your course can actually go into architecture. So 90% will become building technologists or just normal engineers, like structural engineers. But the 10 that do go into architecture, okay, yeah, you still need to find a way, how can I be creative with the materials that are available?
Yeah, that's absolutely fascinating. Completely different from the way it operates in the UK. Do you think that's kind of why we're starting to see shifting, and maybe it's been there longer than I appreciate? I'm not from an architecture background, so we're starting to see real differences in architecture. In a similar way, the way I ground myself, or the way I think about it, is with acoustic consultants. You can become an acoustic consultant, but actually you can do that in many different ways. You can go into the Royal Navy and focus on submarine acoustics, and you can go right through to my route, which is architectural acoustics.
Yeah.
Is architecture kind of widening its field? Is it becoming more specialist architects?
Yeah, and I think that's correct. And I think the interesting thing about architecture is, like, at least that's the things that they teach you in the Netherlands, is that if you go back about 100, 150 years back, architects weren't the architects as they were, like, say, 50 years ago. They were like more so like the architect was sort of like a originally sort of like a sculpture. So they would sculpture parts of the building, and then the building would just be built as how the builder would build the building. Like, okay, you need a room, okay, we need a bathroom, fine. And then the architect would do the facade. And then beginning 1900s, then you start getting more of the architects getting involved into, okay, how can we make when you move from the spectacular outside, if you then move inside, okay, how is then that not a disappointment? Is then not only a facade, it actually becomes all integrated. So then architects start to become more into the interior, and then now you have another shift again, that actually the projects become more like architects become more like project managers.
Yeah,
so
I was going to touch on that.
Yeah, and if you actually go towards the designers, they quite often have junior architects, or they have some other designers within the office that will design certain parts. and then the architects will actually become the project manager from beginning to the end. And especially if you look at the UK, of course, now with the fire issues, etc., and the Building Safety Act, everybody's a bit afraid and everybody pushing it to the architect. You have to decide what we have to use. You have to decide which material is suitable. Okay, then the architect puts it on the paper. As soon as he puts it on the paper, it's a contract piece. So he's the decision maker. He's personally liable. Okay, then you cannot say the architect is just the designer of the facade anymore. It becomes actually more technical, and they become more project managers.
Yeah. So my question was, we're seeing a lot of architecture now subcontracted.
Yeah.
And I think from the 40s, 50s, 60s, that architecture role has completely changed. And now an architect may receive a job and they know a lot or a little about a lot. They have to know everything from door heights through to fire, energy usage. And is that why has the architect's role just changed so significantly that they have to now, it's just too much for one person or one team to know? You have to have those individuals, unless you have a massive architecture firm where you have a specialist in fire, a specialist in acoustics. Is that, do you think, the responsibility of the architect is what I'm trying to say, I guess, is now so big and the liability is so high that you end up needing to subcontract some of those works?
Yes, and I can tell you from experience, even I used to work for quite a large company in London, a big American firm, and they Competence and Fox. And if you look at them, they operate worldwide. The office in London does Europe and the Middle East. But if you actually look at, if we go into the nitty gritty of the design, then they're subcontracted to other architectural firms again. So they are a massive company. There's 200 architects in the office. But if you go to the actual local regulations, it's okay, they hire another company to do that work for them. And then they are, of course, they are the overall architect, but they need to hire in specialists who are more local, who know more about the local detail. And actually the work you do in the London office is less zoomed into this particular individual details.
Yeah. Do you think people that grow up with the traditional architecture view that you turn up on site with blueprints and you design these incredible looking buildings, do you think students maybe become disappointed? I'm throwing this out there with no prior knowledge, but do you think the kind of dream you're sold and the end goal of architect are two very different things now from what they used to be?
I think of course there will always be a smaller scale building. So if you design an individual dwelling, or of course then cost-wise it doesn't make sense to have a whole project team to work on it. So then it will be one architect who will be more diverse, who has to know a little bit more. But then of course the regulations become less strict and it becomes a bit easier. But if you look at energy efficiency, they need to know a lot. And it is no longer like, okay, I make a nice design and then give it to the builder. Good luck, builder, build it. Because quite often the builders don't know. They don't know what the regulations are. They just do. And they go to the builder's merchant or whatever supplier they have to supply the materials and do what the architect tells them. So it's, if you talk about, okay, is it a different role? Yes, definitely. And the majority of work will be, it's in large-scale projects, no longer the individual dwellings, because the amount of projects like that are not that much in UK, unless you want to be just working on small extensions and stuff like that. Then yes, you can become your own boss. But otherwise, yes, exactly. It's a lot different than you go into the profession.
Yeah, you almost need to be part of a big team.
Yes.
It's too much to handle.
Yeah, and especially if you become part of a larger organization, it's not that you, of course, become the principal architect. It can become that you become an assistant or you become specialized a certain type. But you have to be a team player. You have to understand, you have to work together, that you come out for the best results for your client, of course.
Yeah, that's fascinating.
Yeah.
You touched there on energy efficiency, and of course we're here at the Building Performance Hub. I kind of have a few questions around energy efficiency and building performance. The first one being, what training happened for you back then when you went through the architecture college that about energy efficiency? Was it even a thing? Was it up and coming, or was it something that's drilled into you from day one? Buildings have to be pretty, but they also have to be functional and they have to be efficient.
I think energy efficiency was part of it, but of course, because it's a university degree, so they let you discover yourself and do your own research and whatever. So it's you have to do a lot of research into, okay, how does it become energy efficient, and then it gets checked if it's according to the building regulations what you've designed. So they check. But then, to be honest, there's a lot of under architects. There's a lot of copy paste and talking to other students. So what did you do, or how much insulation do I need, and which material did you use? And this is also quite often why I think when I came out of university, there's a lot of materials you choose purely because another student said, okay, that's a good one. I've used that one before, and then the professor, you will pass if you use this membrane because the professor knows that membrane. And then it's quite often it's not the best material out there. It's just because you.
I guess you're also not interested in how much things cost because as a student, you're designing theoretical buildings, and you can use any material.
Yeah, and I think the nice thing about it is like my final dissertation or my final project I did was a hospital, which is of course for one person is way too big to design. But I went, of course, from the overall big design, and then I had to scale down to my final presentation of my 1 to 20 designs and floor plans, to which my mentor said, okay, it's just design the perfect hospital because there's no budget. Normally, if you design a hospital, there's a budget. So just make the best hospital you can design, and then, okay, we can see what comes out.
Absolutely.
Yeah.
Well, that's good. Looking back through your profile, something I picked up on that was quite prevalent through your background, and if I was looking at your CV, rowing. Rowing has obviously been a big part of your life. Did you almost go into rowing as a career instead of architecture? Because it looks like you've had quite a few roles, including some pretty big names, some pretty big teams.
Yeah, exactly. It was a bit of a surprise, but we're sitting down now. But if I would stand up, you'll see that I'm quite tall. And when I went to university, thinking I was going to just be really focusing on architecture and really do that, and then someone convinced me to show up once for the rowing recruitment and to see if I would like it or not. And then I thought I'd just do it for 6 months just to be fit, etc. But then I got selected for the first freshman team, and then we became national champion as freshmen. So it's the national freshman champion in the Netherlands, which then resulted into more and more. And then I won the development cup is done there. I think we won that, or at least we won loads of races there. Then I ended up in the national student team, and then trained with the national team. And then I constantly kept getting injured, so I was like, okay, it's not it. I thought I was going to go to Beijing, but I wasn't good enough, because at least I kept getting injured and then trying to come back, so I wasn't going to make that. But then they asked me to coach, and then I started coaching the top club in the Netherlands, and then the Dutch under-23 team. So I was rowing, coaching, etc. So instead of putting all my focus at university, it was then, okay, I have to combine it too. And then at university, then they told me, so no, you're young now, so you can be a rower now, or you can study when you're 50. You can row when you're 50. Yeah. So yes, you stay a member, if you stay working at university, but then for maybe 20% or something like that, focus on the rowing. So I focused on the rowing, and then at the end, it's okay, I still need to finish my degree. So I finished my degree, and then I ended up with a British girl who was in the British national team. So then we said, okay, let's move over to the UK.
And then that was also on my question list. You've studied in the Netherlands. You've competed with a national level for the Netherlands, and then suddenly you're here in the UK. You've moved not far away from where we are now at the hub. Yeah. And that was going to be my question: was it work or was it love? It's always one of the two.
It's exactly my girlfriend at the time. She wrote for the GB team, and then lived in Henley-on-Thames. I'd already competed several times in Henley-on-Thames. coached in Henley on Thames. I met her in Henley on Thames. So then I thought, okay, let's move to Henley for the Henley Regatta and stuff like that.
Yeah, nice place. Yeah.
And yeah, we lived together for like a year and a half, 2 years, something like that. And then this is also which basically then moved me to work for a boat building company. So in the beginning I thought, like, do I need to go into architecture here, etc. But then the first job I ended up was a company that was repairing boats, but they were starting up their own boat building company to build boats. And I found it interesting because they were really, really deep into carbon fibers, glass fibers, how to make these hulls, etc., which of course are new technologies. And the owner of the company used to work for the Formula One. So he used to be one of the engineers for the Lotus team at that time to build Lotus Formula One cars. But then when Lotus went bust, he went into boat building. So then he was trying to set up this amazing new super fast carbon fiber boat, and he pulled me in because he knew that I had some knowledge about how the Dutch built their new rowing boat.
Yeah, I like it. That's true British style. We take from whoever's winning at the time.
Yeah, exactly. Yeah. And I think it was I made a hard decision because I said, okay, let's set up this business and see. So I agreed to work for a minimum salary, but in return he would teach me all the technologies about glass fibers, carbon fibers, how to make it, how to vacuum mold things, etc., to make something.
Yeah. So you invested in yourself. You worked for minimum wage so that you could learn.
Yeah, exactly.
That's really cool.
Yeah.
Cool. So you started with the boats, and you ended up working for one of the biggest names in building performance, which is kind of how we then bumped into each other and got you down here at the hub. So you ended up becoming was it sales for Sega first? Was it a sales role?
Yeah,
so kind of a technical.
Yeah.
Technical
I think it's within Sega. They have I believe they have a very good system to say if you start working for Sega, that we want everybody to start in sales first, and not to sell the product, because within Sega, even our sales reps, we don't call them sales reps, we call them trainers or advisors, etc. Because the key thing is that they understand what the need is on the building site. So even if you end up in product development or you end up in whatever communications or whatever, you understand what the final customer needs, which is slightly different than how in the UK, because in the UK materials are quite often specified by the architect, who also doesn't understand quite often what the installer needs on site. But I think for the Sega employees to have such a close relationship with the installer on site, you understand that a product you design in the lab under lab conditions doesn't always work on a construction site.
Yeah.
So you need to really see what the issues are for the builder on the construction site, like dust, like it's always messy on the building site, it's raining, it's cold, it's windy. Okay, can you then make a tape that sticks down, but as soon as one wind gust comes, it pulls it off again? Then it might be okay for you, but it's impossible or very, very time consuming otherwise to build with it. And therefore I think it's quite a good way for Sega to go this way. So that's what I did first. So I was a year and a half in sales, and then became application engineer to be sort of the link between product development and then my region, which is UK and Ireland.
Yeah. So what does an application engineer do? What's your... It's a role you see in my mind. You go, application engineer, do you play with different glue and stick things together?
Also.
Or is application, are you much more trying to... Is it product improvement? Is it product R&D, as we would see it?
I think it's all. I think the interesting role of product development, but mainly application engineer, is sort of a link between product development and the applicators on site. So part of it will of course be complaint handling, and of course it will be our local representative who will deal with complaints normally, and if they can help you straight away, they help. But if it's technical and they're also not sure what caused an issue, then application engineer will go out and make sure, okay, what could be the issue why the applicator has issues with their installation of our product, because it should be able to work in any condition.
Yeah.
So we need to understand the local conditions, but also we need to understand application engineer needs to stay on track with the local building regulations, where influences into the government to talk to them and say actually, or we need to be influenced into the British standards and the European norms to make sure that if they write new regulations or norms, that they are written fairly towards the manufacturers. We do the research into what materials are needed in a certain area, like let's say in UK now with the fire-rated materials. Okay, this is something new for tapes. Normally tape manufacturers, they don't have to deal with fire regulations, but in the UK it's a big topic. Okay, how can we make a fire-rated tape and not just say, okay, we got fire-rated carrier, this is fire-rated, because we see some competitors on the market that basically cheat the system. They test their carrier and then add the adhesive on later on. If you then put it on fire, it burns. I tell you that. Yeah. So it's actually illegal what they're doing. But okay, it's a bigger topic. So yeah, okay.
We'll spill the tea when the recording stops.
Yeah, and so yeah, so it's part of that, and it's also together with of course materials on the market constantly need to improve. Because we know or we believe that we currently make the best materials on the market. Okay, but it's a lot easier to copy a material than make a material. So as soon as we have a good material on the market, we know our competitors are buying our materials. They go to their suppliers and say, okay, can you copy this? And then of course a few years later we see a copy. Quite often they can't copy 100% because there's quite a lot of secrets in the product which we don't talk about or don't show. And only through some experiments we can prove that they're different. For example, together with the local sales team, I did recently
set fire to them. Yeah.
Set fire to them, or I do let them apply it at 5 degrees, for example. Okay, quite often, especially if you talk about adhesives, these are important facts, because on the building side, especially in the UK, we know it's not summer in the UK every day. Yeah, the most of the time, especially at 8-9 o'clock in the morning, it will be 2-3 degrees, especially in the UK. Okay, quite of these materials don't work. So then I was on a project site in London last week where a customer used all our products but one of the other competitor tapes. So why did you use the competitor tape there? Why do you not use our product? Oh, because it sticks so well. And that's okay. And what do you mean it sticks so well? Well, it sticks very well. That's okay. Also in the morning? No, we can only stick it down at 2 o'clock in the afternoon. I said, well, only at 2 o'clock in the afternoon? Well, because then it's warm enough. Otherwise it won't stick. So they have to wait, and then they have a window of 1 hour when they can tape things, and then there's the time they can't use any tapes. Yeah. Right, good luck working on a building site where you can only work 1 hour of the day. You basically, it's impossible.
So Sega must have a bunch of chemists. I mean, in my mind, I can just see test tubes and crazy chemistry going on. Is it like that back at the base, or is it, because you must be inventing stuff that sticks? I mean, I've used some of your tapes in ways that you would be horrified, but I mean, even just holding them sometimes, or give a shout out to Sega. Oh my God, if you hold them for too long, the chemical reaction will happen on your finger, and you peel the tape off and almost lose a layer. Yes. They are strong. We've used them. I mean, you could walk around the hub here and it's holding some pretty major infrastructure together.
Well, and I think we can. I can show proofs where we can stick on certain substrates. Of course, not every like it's really dependent on the substrate, of course, as well. But on some substrates, I can stick things down, and I can tell you, with human power, you can't take it off. It's impossible to take it off. And the interesting thing is that there's a difference between the adhesives. That if you use, you've got two types. Well, there's loads of different types of adhesive, but the biggest difference is you've got pressure sensitive adhesives, or PSAs, and you've got chemical adhesives. And the chemical adhesive is all the material we know, for example, now, like the duct tape, and there's nothing wrong with the duct tape. Duct tape was actually developed by the American Army for the Second World War, a quick fix to just whatever, the arm is blown off, or I need tapes, or whatever, I need something taped, something really quickly, which worked really well. The only thing is there's got certain chemicals in these tapes that as soon as it comes in contact with oxygen, it sticks. But this chemical reaction will never stop. So then, I'm not sure if you've ever seen a tape after 2 years, but the duct tape after 2 years is powder. It's destroyed. The glue is just gone. And if you talk about the pressure sensitive adhesive, it's an adhesive that stays like that for hundreds of years. Yeah, not 10 years, not 20 years, not 50 years, hundreds of years. So the Sega adhesives are really developed to last the lifetime of the building. As soon as it's stuck on, it needs to last. The only thing is, it's a PSA, so pressure sensitive adhesive. You stick it down, you have to press it on.
You have to use the rollers, yeah.
Well, it's like, we advise the rollers, but if you just hand pressure
I
is
have very
is
delicate
enough.
hands, so I tend to like the rollers.
If you look at the official European norm, it's 15 newtons, so it's 5 kilograms of pressure.
Not very much.
It's not very much at all, and that's how these products are tested, and this is how they're developed. And if you talk about how our factory looks like, we actually have 2 main factories in Switzerland, and in the 2 main factories, in one of our head office where our sales team comes as well, we have our quality management team, who of course have some materials to test these and etc. But then we have our innovation hub, which is in Schachen in Switzerland. It's like 50 minutes away from the head office, where it's quite secretive, where we have, of course, lots of chemists and lots of...
I can just imagine what lab coats and crazy hair and small explosions.
I wish.
Quite as exciting.
These are not. Of course, for them it's interesting, but we do have like quite a few, really like material scientists who know really the ins and outs of adhesives, and I think that is also crucial for Sega, and this is also why I wanted to work for Sega. When I applied for the job at Sega, I was a bit cheeky during the job interview. They asked me, okay, why do you want to work for Sega? And my answer was, you tell me why I should work for Sega, because I won't work for you if you're not the best in the market. And then they had to basically do sort of Sega sell themselves to me, which they did very well.
Yeah, that's a 50-50 whether that substantially backfires or whether it really worked in your case, where they realise they've got a candidate they need to keep.
Yeah, well, they asked fairly afterwards. I said why I asked, and they said, well, it will be difficult to sell, otherwise I only talk about price if I cannot talk about quality. So I just basically had to know why it was that they were the best in the market and in highest quality. And I think it's within Sega. I think that's the crucial difference for Sega, is that we are the actual manufacturer. Yeah, there's quite a few tape brands now in the market, and air tightness in the UK and wind tightness is even less in the UK is still not a big topic, which I don't understand, because there's a lot of proof which basically says just insulation on its own doesn't make buildings more energy efficient. It's a combination of the materials. But of course, the decision makers are not they get influence from loads of different angles, and some people try to build cheaper, and therefore try to avoid it.
You'd have probably seen or known of presentations I make with my Atma hat on, where I say, wind going through insulation means you basically have no insulation. A fridge doesn't keep things cold if the door's open, so why do we build our buildings that way? It just
exactly.
I'm not sure that will ever quite be fixed. But as a country, we're slowly getting there. But it's quite scary in the air tightness world, where we were the world leaders in the way we were doing, the amount of testing we're doing. We're definitely world leaders in the 100% testing market.
Yeah.
But our targets just are nowhere near where they should be.
Yeah.
And that's
and even if you speak to the BRE, so I've spoken to the BRE about their previous sub-calculations. I say, well, if I change air tightness in my sub-calculation, I barely get any improvement in energy efficiency, which is ridiculous. To which their response was, yes, we are aware that this is incorrect. The only thing is, it's too complicated to change the formula, because it will then have a counter effect on all the other things, and therefore you can get too many positives of air tightness. It's like, yeah, but it's like 1/3 of the energy efficiency is air tightness. Or if you now talk with the new vacuum with more insulation, it's even more important. It's about 40 or 50% of the energy efficiency is air tightness. I think the interesting thing is I just read it last week about a statement from from the Passive House Institute, from the founder of the Passive House Institute, who basically said he was a physicist. He wasn't into building construction at all in the beginning. To which he said, like, okay, like for years the construction industry has been investing into more insulation, but the outcomes were that the buildings were not becoming more energy efficient. So the insulation was added, but then it didn't become more energy efficient. This is why he started the Passive House Institute, to do the research into, okay, what is then wrong? And this is how he then developed the whole Passive House Institute movement to say, okay, there's loads of more factors involved into energy efficiency than just put a woolly jumper on. And I always try to simplify it to our customers and to our sales team if we get new sales employees, to teach them, just like, look, if you think about it, insulation is like a woolly jumper. It works very well, but only if you protect it. If you go skiing with only a woolly jumper on, as soon as you got movement, the air will go straight through the insulation and you're not warm anymore. And then it clicks in the head.
If you have your ski jacket open and go down the slopes, the air comes straight in.
Exactly.
It's very frustrating. I think we're making gains in the UK. We now have the HEM model coming, and I'd be really interested to see if they've adapted. Supposedly it's a bit more realistic. We all know PHPP, the Passive House software, is largely the best model, and I'm forever saying to people that come to me and talk about air quality and air tightness. Air tightness doesn't create poor air quality. A lack of ventilation creates poor air quality.
Yeah.
If super airtight homes weren't the ideal, then the whole Passive House thing just wouldn't exist. Well, and I try and bang that drum as much as I can, and I just sometimes I stop arguing with people or stop debating with people, because if they can't accept my point of view and they can't accept the science, then you're never going to change their mind. We just need to move on, and it's only in this country, I think, sometimes that regulation is what drives people. People will build the minimum legally worst building they're allowed to build.
Exactly.
And be happy that they've met building regulations or just squeaked building regulations.
Yeah.
And you look at self-builders generally build substantially better homes because they're going to live there. And I think that culture of thinking more of the homeowner needs to be much more ingrained in UK construction.
Yeah.
Because we just need to do more. We need to think about who is going to live there.
Yeah.
I always used to say, when I was out in the field doing blow door testing, I used to think, what if this was my parents? What if this was my gran that lived in this house? It wouldn't be acceptable. So why should it be acceptable? Because we don't know who's going to live there, or we don't particularly care about who's going to live there. We need, as an industry, as a construction industry, we need to do better. And if I'm starting to get to the point now where I believe regulation, at least in the UK, is the only way we are going to enforce change. So it has to come from the top, because we've all pushed. I mean, Sega have pushed from your angle of membranes. We've pushed from our angle of more testing and collecting the results, doing reports and data. We've had the insulation manufacturers. Everybody's on the same page about what good buildings look like, but we just can't seem to put the bits of the jigsaw together and make that happen.
Well, and exactly, and it's what you say is about, okay, there's nothing wrong with airtightness, and if you do a blower door test, it's like you're allowed to tape up the trickle vents, and so if you do your blower door test or your air tightness test, you close down all the ventilation channels just to check the performance of the building envelope. Air tightness is the performance of the building envelope, and if you then say, okay, but I don't want it to be too airtight, because unfortunately in the UK building regulations, the weirdest thing is that you get punished for building too airtight. There's many building sites I walked into where they say, we want your products so that we get an air tightness of 4. Well, it doesn't work that way. It's like good quality insulation, you get air tightness of 0. And if you do a poor insulation, you get an air tightness of 10. It's purely down to the quality of insulation, what air tightness you get. And if you then want ventilation, because you got the airtight of your natural ventilation, that should be down through the ventilation channels.
Yeah.
And a lot of people talk about, but the old Victorians, they built so well. If you actually look well back in the Victorian times, we didn't use dot and dap plasterboard. We used to wet plaster our walls. We used to put sheep's wool insulation crammed into around our windows to make actually the envelope as airtight as possible. Even the old Victorians already knew this. And then the ventilation was always designed to, through ventilation bricks under the floorboards, come up through the floorboards and being sucked out through our chimneys, back out again. So they actually had a designed ventilation strategy, which according to the building regulations, if you do natural ventilation, it should be designed as well. But we know nowadays it's not. We just don't have a chimney.
Some slots in a window, and we
have a trickle vent.
Ventilation.
Yeah, and then there's not thought about how this air then will flow from this room to the next room and which direction.
We see all the time terraced buildings or single aspect apartments with just a couple of trickle vents and a bathroom fan that runs for 15 minutes, and then we wonder why we get mold everywhere.
Yeah, exactly.
And then what happens a lot is I'm the person that gets the call, or the national press will contact me and say, airtight homes are causing mold and damp issues, and I'm like, whoa, there's no such thing.
Yeah.
The problem is the lack of ventilation. The whole thing has to be completely harmonious. I'll ask you a question. We'll jump into the questions I always ask people. The first one, I guess, is this is the Building Performance Podcast, so what does building performance look like to you? If I was to say for you to describe building performance, what does it mean? What does it mean to Stan?
Well, for me, building performance means, and if you go back to the Future Home Standard or even the Scottish Passive House equivalent, if you talk about the building performance, it's about how the building itself performs. Yeah, if we talk about the future energy, and we talk about green energy, net zero, all these type of things, I think the crucial thing is that the building itself should perform, and not think about, we just keep building the same buildings and we just add loads of solar panels on the roof and this will resolve the problem, or we just electrify the heating system. If you electrify the heating system, we are all aware that if you don't make the building envelope perform itself, so the building perform by itself, so make the building as energy efficient as possible, then you have very high peaks in your energy network, which will push up the issues with the peak of the network anyway, because we're all going to drive electrical cars, which will all start charging at between 4 and 8 in the evening, which is the same time as when we have to heat up our buildings, because that's when it gets cold. So all our heating systems turn on and we come home, so we warm up our houses. So we only make this peak higher and higher and higher. And actually, if you make your building envelope perform as efficient as possible, you can have a more controlled heating system in your building. You can keep your house at a constant temperature instead of saying, it's only warm between 6 and 10 in the morning and between 4 and 10 at night, because then we drop down this peak in this grid, which will reduce costs for the government in regarding to the grid, in usage, in all these things. There's so many things involved by just building to a higher performance of the building. And then if you then talk about solar panels, we should still use those. Yeah, why? Because we can still use it to charge a car, and you can still use it to, send back to other networks that need energy for manufacturing, etc. So you can still use the electricity, and it's electricity. You can still say, if you have a very well performing building, you can easily switch to electric heating. It's not the problem. And then you can choose loads of different systems how you want to change it through an air source heat pump that runs on electricity, or electric heaters, or anything, or radiant heaters. All these things that I've seen a lot of lots of large scale building companies, or like the house of the future, etc. So one of them, radiant heating or whatever. Yes, it's going to electricity. So then, you work in a way, but you still create then this peak in electricity. If you just make the building envelope as efficient as possible, then the amount of energy needed is so little. And it's proven that if you build a passive house versus and I'm not saying you have to build passive, like I think people in the passive house, they're doing a great job, great focus. I personally think if you're going to push it out to a global network or even a national building method, you have to learn from what the Passive House Institute does. So maybe you don't get the 90%, but you get 75% more energy efficient buildings. All right, that is a reduction of 75% of the energy of electricity grid needed for this heating or like demand. Yeah. And I think the first step will be building envelope performance.
Yeah, and I've been very outspoken about, and I think I hold very similar views to you. The Passive House is the gold standard. I think they now even have Passive House plus. Yeah, they're a crazy good standard. But the Passive House is widely known. Everybody in our industry agrees the Passive House is the gold standard of building a home or a building. And I agree. I think you have this kind of Enefit level, which is kind of for retrofits. But in my mind, if I was going to build my own home, that would be my target. It would be, yes, I would love to get air tightness at 0.6, but if I got my air tightness at 1 meters cubed per hour per meter squared at 50 pascals, great. If I can't fit 450 mil of insulation, but I can only fit 400 mil of insulation, that's also great. If we can learn from the Passive House Trust, and one of the key things I think they do, the Passive House Institute and the whole PHPP model, it's not necessarily even about the materials, the depth of insulation. It's about the level of control and inspection. Yeah. And having a Passive House certifier check your work. I think the UK construction market, particularly the mass market, could really learn from either having heavier enforcement from building control, like we used to, or bring back the clerk of works on behalf of the client to have somebody that's always there and checking, has that been done properly before it's closed up? I need to check that. I need to inspect it. I think the actual regulations we have right now are not far off of that. And I think if we take one more cycle of the regulations and add in some quality control, we can take what we currently have and we're not far from it. But if we keep building and saying we need to put this level of insulation in, but we leave gaps, and we need to have this level of air tightness, but we're people are taping stuff up or ripping out mastic after the air tester leaves, then we're never going to get there. We're just going to keep doing exactly as you identified, which is add more and more insulation and more building materials, but not actually improve the energy usage.
Yeah. But I think if what we learn from the people that build passive for the first time here in the UK, they're all really afraid of air tightness. That's not anything else. They're all afraid of this air tightness. But if you look at Norway, if you look at Germany, the 0.6 is standard. It's building regulations. Yeah. So it's not that complicated, and it's like, okay, yes, we need to teach the trade that airtight is important, and I'm also not saying that it must be 0.6. Like as a UK, we can say, you know what, we say 1 or, but I think this whole thing about I think the natural ventilation versus like mechanical ventilation, this is a limit towards building new houses. Why? Because the new houses being built, it's all basically pushed, especially the large-scale house builders, it's being pushed down to cost, which I understand, of course. They need to make money, they're all part of shareholders, they need to explain their profits, etc. But if in the regulations it says you must install a mechanical ventilation system, it's compulsory to have a new build house, must have a mechanical ventilation system, then a builder will not get punished because they build good quality homes and then the airtightness accidentally get to 2.5.
Yeah, I've had it recently with a disgruntled ATMA member who's come to me and said, the building control officer has said that this building is too airtight. He's asking me to retest it with a window slightly ajar. Yeah. And I'm like, oh my word, that just ruins the whole, what is the point of you being there? You may as well stay at home, save the CO2 from your vehicle and make it all up. It completely just takes the mick out of our industry. It devalues the people doing the testing. It devalues the reason you're there. If the enforcers are doing that, and I've reported the enforcer, and I've got absolutely nowhere. So if you're listening, then you know who you are, and we'll be talking about it in future podcasts. But we can't have a world where we have the regulations, but the people enforcing them don't believe in them, because it just creates this. Don't worry about it. I'm not worried about it, so you don't need to be worried about it. It's just a number that goes in a box. That's absolutely wild to me.
Well, and I think also the thing, if we talk about air tightness, and I think for good quality air tightness, and I think the government is being pushed towards by the big house builders. They say we don't have the skill in the UK that they can do this. But if you speak to quite a lot of the training facilities, or here in the Building Performance Hub, we as a manufacturer, we offer free training to use the materials. We come to site, because we all know to achieve air tightness, it's down to, yes, of course, it's the materials, how easy it is for the material to work with. So we try to engineer in that it's the materials are really, really as simple as possible to use. So any idiot can use it. Of course not. The stores, of course, are not idiots, but okay, we try to think, okay, if I'm just had no training,
so you didn't necessarily have an installer.
Never training.
I've done exactly that. I've never formally been trained to install membranes, and we did the back of the house recently. Lee Thompson and I did some of the membranes, and we were really pleased how easy it is to install. I guess that's part of.
And therefore it's down to application, and that's just also for us as a manufacturer. It's important that we have feet on the ground.
Yeah.
Like, it's very easy to be the manufacturer, go to an on-seller. Okay, here, this is our product, sell it on. This is the base price. Any price you put on top of it's profit. Good luck, and all right. And we know those brands are out there who just try to make as much money as possible, but at the same time, on site, they use all these airtight states, but can't get airtight. It quite often is quite a simple thing. If we go to site, we say, "Oh, just look at this," or everything. And we even tell our customers, if they do a blower door test, invite us to come round, because we can be there when the blower door test is there, and then they do the test. I think it's there, and then we get materials in the car and tape it up for them. And for next time, and the people we work with, like on a regular basis, for them it's easy. We get people that build airtights down to 0.0. I think the best I've heard was 0.04. All right, that's probably the most airtight house in the UK, but it's possible.
We'll definitely be auditing that one.
Yeah.
The end of every podcast, I always ask the guests the same 3 questions, and that gives us some consistency, allows us to see where different people are in the industry.
Yeah.
So, first question: if you could change one thing right now in the construction industry, what would it be and why? You could change one single thing.
I would make it. I would remove the limitations on air tightness, and I would make it down to that an air tightness level. It would result into a quality ranking of quality of builders. So if you as a contractor builds down to 0.6, you're a level A contractor. If you build your houses down to 0.3, you're a level B contractor. If you build it down to 5, you're a level C contractor. And if you're something like that, I think, because then
maybe you could restrict an EPC. So if your air tightness level is 4, then no matter what you put in, you'll only ever get a D or an E.
For example,
that could be good. That could be interesting. So that's the one thing you'd change.
Yeah, because from studies, and of course we have full-scale houses, and we have our own blower door test rooms and machines, etc. We just know there's an interesting study in France, which they called the Easelgate. Instead of Dieselgate, they called it Easelgate, where the mineral wool insulation manufacturers sued the reflective manufacturers in regards to them telling them about, we achieved this airtight, but you also know it's not true. There's reflectiveness. If your reflectiveness is towards the outside, for example, then heat always moves from warm to cold. So if the reflectiveness is towards the outside, how does it reflect the warm air leaving? It doesn't. So if you then say it has a UV, it's complete nonsense. So they sued each other, to which the judge in the court said, actually, I can't make a judgment because we really don't know how the other installations perform. And then they let them do a study, and they actually built houses, one with air tightness 1, with 3, with 5. And they say if you have an air tightness of 5, you have a loss of energy performance of your building of 75%.
Yeah, I smile because I know about that. I was also involved in that many
Yes,
moons ago. Yeah, I was personally part of that. So that is interesting. Okay, question number 2. Who is inspiring you right now? That could be anybody. That could be from family. That could be work. That could be celebrity. Who's inspiring you?
I think that's my wife. I think that's Sophie. I think she's very diehard, and she's always saying, "Oh, I don't know," but she's Wonder Woman. She's unbelievably intelligent. She studied biomaterial sciences. Decided that she doesn't want a job looking through a microscope all day, and then she said. Then we just basically talked about what do you want to become? What did you want to become when you were younger? She said, I want to become a doctor. And then just jokingly, we said, just become a doctor. What did she do? She became a doctor, and she just gave birth to my now almost 6-month-old son. And she's like full on carer for him. And at the same time, my mother-in-law is ill, and she's fully supporting her. So I think 100%. So.
Oh, that's awesome. We'll definitely clip that, and we can
text
that to you to send on. Yeah. Okay, last question. Tell me something that you would have done differently in your career if you could do it all again.
I think that's very
little thing.
I think it's very difficult because it's like everything has influence on things even without you knowing it. It's like. Like if you try to go to the Olympics, like that was my goal and I didn't make it, then all these years I wasted trying to train to get there. But at the same time, of course, you learned a lot and a lot of determination and how to be, like a lot of people think rowing is just physical, but it's team. You have to do 100% exactly the same thing as the other crewmates. So if you do one thing slightly different, you go slower. So you have to be really, really analyze, push, focus, and do it over and over again. And you learn from every mistake. So I think the best teacher is making mistakes. And I think this also within Sega, we teach the new employees what we call 4-step method, especially let the customer make a mistake, or even let our own employees make a mistake. Let them realize they made the mistake. Let them improve on their mistake, and then they
won't make the mistake.
They don't make it again. And I think, and if you read to all the, I've read this thing even from Amazon and from Musk and whatever. They make mistakes on purpose. Just do it. Make a mistake, and then we know it doesn't work.
Yeah.
Instead of talking about but that's not going to work. But if someone believes in it that will work, just do it. Okay, of course you have limitations in regards to costs and etc. But if you just limit yourself to things, and that I think that goes back also to architecture, sort of like out of the box thinking. It's like I want to do this. Okay, in the Netherlands, of course, you learn the technical with all these materials. Okay, but you have to then learn how to think out of the box, what you can do with these materials. Try to make something that does work. Of course, it's the same as the regulations in the UK. Like if you then don't make it work, you fail your real project, etc. So it has to work in the end. But if you don't take risks, you never achieve things in life. Then you just become mediocre, average. And I think so. Yeah, as long as you don't affect other people, I think that's it. So if you don't downplay other people by taking risks, then. Yeah. So then, from that thing is what I've done differently. Nothing, because everything taught me something.
Awesome. Well, thanks so much for coming on the podcast. It's been an absolute pleasure having you here, and we'll see you for the next episode. Thanks.